Hello everyone, I'm Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on single-phase full-wave controlled bridge rectifier. So here what we have covered till now, first single-phase off-wave controlled rectifier with R load, L load, RL with freewheeling load, RE load, RLE load. And now next we have covered single phase full wave controlled semi-controlled rectifier in that symmetrical asymmetrical. So today we are going to have a discussion on with RL load, RLE load, RE load. After that full converter, this with freewheeling diode, that is also comes under the semi-converters. So that we will discuss. So first I will explain. So single phase off wave controlled bridge rectifier. So now here first one, single phase off wave controlled rectifier. So here in this we have total 4 thyristor T1, T2, T3, T4. The notation is T1, T2, T3 and T4. So this is the notation, and here we are connected one load. That load is highly inductive. Load may be RL or RLE type of load. So now here we are giving the supply. So at this terminal A, so this is connected to this one, and B negative terminal is connected to this one. This is the circuit configuration of single phase full wave bridge rectifier. So now here, so now I am triggering T1 and T2 during positive off cycle. So T1 and T2 are triggering. So T1 and T2 are triggering. So this is the supply voltage, and now here this one, this is the load, this is the output voltage. So now I am drawing the supply. So this is the supply voltage. So here this is the plus and this is the minus. And why T1 and T2 are triggered during positive off cycle? Because anode of the T1 thyristor T1 is connected to plus, and cathode of the thyristor T2 is connected to the negative of the supply. So because of this reason, T1 and T2 are in forward conducting mode when they are triggered at alpha. So now here this is the supply T1. This is here is the T1 thyristor will conduct, and next here this is the load. Here T3 is will conduct. So now this is the supply voltage Vs. So now here output voltage equals to V0. So during negative from this, it will T1 and T2 will conduct up to 5 to 5 plus alpha. So now here the output voltage V0 equals to Vs equals to Vm sin omega t. So here it is a RL type of load, means here RL and RLE type of load means there is an assumption I0 is constant. So that is I0 is constant only. This is omega t. So now here this is a VAB. So that equals to Vs, that equals to Vm sin omega t. And next this one is a VBA. So that equals to V minus Vs. So that is minus Vs, that equals to minus VAB, that equals to minus Vm sin omega t. So now here Vs equals to this one equals to plus VAB. So this is the output voltage. So now during this is the Is and this is the I0, and next here these are the thyristor currents IT, and this is the thyristor current IT. So now here thyristor currents equals to source current equals to I0. So here Is equals to I0. So now here what about the thyristor voltages? Thyristor voltages equals to IT. So now this one is. Now here what about the thyristor voltages equals to, here T1 and T2 are conducting. So this is the thyristor voltage, and now this is the output voltage. So here T1 and T2 are conducting, means they are short circuited up to 5 plus alpha. And now here this is the remaining voltage is the, this is the T1 and T2, and next what about it will conduct up to this one. This is, so now here this is the VT3 and VT4 that we will explain next. From pi plus alpha to 2 pi plus alpha, this is the 2 pi. T3 and T4 will conduct. So now here, so that we will see, so now here this is T1 and T2 will conduct. So now here at pi plus alpha, T3 and T4 will conduct. T1 and T2 and T3 and T4, this is a pi plus alpha. So now here alpha, this is the pi. Now here during this condition, so now here, so here T4, so this is a negative and this is a positive. This is a negative of cycle. So now here this is a negative, means cathode of the T3 is connected to negative, and positive terminal of the supply is connected to this anode of the thyristor T4. So the diagram, it looks like this. So now here this is the plus is connected to anode of the T4, and this is the cathode of the T3 is connected to the negative. That I am explaining. So this is the supply voltage, and now here this is a T3, and now here this is, here is a load we are connecting. So now here what is T3, here T4 are conducting. This is the load, and this is the I0, and this is the IS. So now this is the VS voltage. Supply voltage is also this is a minus VAB. VS equals to V0 equals to minus VS, that equals to VAB, minus VAB or minus VBA. Sorry, VBA only, plus VBA. So now this voltage will conduct. So this is a plus VBA. So now here IS equals to minus I0. IS equals to minus I0. So this is a I0 and this is a minus I0. What about the thyristor voltage VT3 and VT4 voltage 0? So this is the thyristor voltage of VT3 previously. So this one VT1 and VT2 will conduct. Here VT3 and VT4 will conduct. So these are the thyristor voltage waveforms. This is the output voltage waveform. This is the source current waveform. So from alpha to pi plus alpha, so it will follow the supply voltage, and next here, so that source current equals to I0. From pi plus alpha to 2 pi plus alpha, this one equals to minus I0. Here conduction time equals to pi plus alpha minus alpha equals to, that is pi only. Conduction time for this SCR, each SCR is a pi. So now here if you see the V0 average equals to 1 by pi. So this is alpha, this is 2 pi, pi 2 pi plus alpha. So now here the average value equals to 0 to alpha to pi plus alpha. So 1 plus, sorry, this is Vm sin omega t, Vm sin omega t. So that equals to 1 by pi, pi plus alpha up to 2 pi, pi plus alpha it will conduct, that equals to 2 Vm by cos alpha. V0 average equals to, this is the formula. So now here it is, now what about the circuit turn off time? Circuit turn off time means the time for which SCR is in reverse bias. So here SCR is in reverse bias up to, so here pi minus alpha, here up to pi, so it is conducting up to this one. But here from pi to alpha to pi, it is in reverse bias. Omega TC equals to pi minus alpha, TC equals to pi minus alpha by omega. So now here this is the equation 1, 2, the circuit turn off time, third is gamma of t equals to pi. So these are the three equations. So first V0 average equals to 2 Vm by pi cos alpha, and next TC equals to pi minus alpha by omega. and gamma of t equals to pi. So now here the circuit turn off time means here output source current equals to here next 3, fourth one equals to is it average value equals to I naught into, so now here I naught into, so pi by 2 pi that equals to I naught by 2, and fifth one is the IT RMS equals to I naught into square root of pi by 2 pi that equals to I naught by root 2. Now here another thing is from alpha is greater than 90 and alpha is less than 90. First I will take alpha is less than 90 and alpha is greater than 90. So now here in this case V naught is greater than 0 and I naught is greater than 0 and P naught is greater than 0. From here power is transferred from load to source to load. Here power is transferred from source to the load only. It acts as a rectifier. It acts as a rectifier. But here in the from if it is alpha is greater than 90, this is the 90, means here this in this case somehow here, so now here in this case output current is negative, output voltage is positive and P naught is negative, and now here power is transferred from load to the source. Here power is transferred from load to the source during from if alpha is greater than 90 and if alpha is less than 90. So this is the most important. Next, sixth point and seventh point. So now here what are the first output voltage formula, this one and this one, and next these are, and next case here harmonic analysis for this circuit. So first here harmonic analysis means suppose let us take one Vs equals to, this is the Vs maximum value and this one is the one waveform, square waveform omega t, and this is the Vs. So now for this case Vs equals to this is the maximum value. Suppose V of t equals to sigma n equals to 135 infinity, so 4 Vs by n pi sine of n omega t. But here this waveform is starts from here this waveform is starting from here from alpha to here, it is starting from alpha to pi plus alpha. So for this particular case Is equals to Fourier series equation n equals to 135 till all are odd numbers and infinity 4 into this is I naught, so by n pi, so sine of n omega t minus n alpha. So now here for this source fundamental source RMS current, that is 1 is equals to Is1 equals to, so now here for I naught fundamental means n equals to 1, so by pi by root 2, so that equals to 2 root 2 by pi, so into I naught. So now here Is, so total source current RMS is equals to, so now this is a I naught only, so I naught, so now here G equals to Is1 RMS 1 divided by Is RMS, that equals to 2 root 2 I naught by pi. So by I naught, that equals to 2 root 2 by pi. So this is the distortion factor. And now here what about the THD? THD equals to 1 by G square minus 1, that equals to, if you substitute this G in this, and you will get the 48.34% THD. So now another thing is here THD equals to 48.34. Now here another formula is input power factor. Input power factor equals G into fundamental displacement factor. So G equals to 2 root 2 by pi into, so fundamental displacement factor equals to power factor, input power factor equals to 2 root 2 by fundamental displacement factor is a cos alpha. In another way also we can derive this input power factor equals to P in equals to P output. So that equals to P in equals to P output means Vs Is cos phi is equals to V naught average and I naught average. So that I naught and Vs are both are same. Vs equals to cos phi equals to V naught average equals to Vm by pi. So now here cos alpha divided by, so this Vs means here Vm by root 2. So Vm gets cancelled. So now here 2 root 2 by pi cos alpha is your input power factor, cos alpha. So input power factor means here that is cos phi. So now this is the input power factor. So now here what are the formulas here? V naught average equals to Vm by cos alpha, pi cos alpha, this is the circuit turn of pi minus alpha by omega, gamma of t equals to pi. And now here I naught average and IT average, IT RMS, I naught by 2 and I naught by root 2. And next here is alpha is less than 90 means it acts as a rectifier. Of alpha is greater than 90, it acts as a inverter. So here in this case power is transferred from source to the load. In this case power is transferred from load to the source. And now here another thing is here 7, and next 8th formula is harmonic analysis of source current. 9th formula fundamental source current RMS value, total RMS source current 10, and 11 is the distortion factor equals to 2 root 2 by pi, and THD is 48.34, and next input power factor is 13 to 1 is 2 root 2 pi cos alpha. So now next case, this is RL case and RLE case. The load is highly inductive load. Now let us discuss the load is RE type of load, R and E type of load. In this case, what will happen? This is the alpha and this one is a pi minus theta, and this is a pi and this is a pi plus alpha, and here is somehow theta is somehow is here. So now this is the theta. So now here I am dividing the limits. So here pi is 0 to pi, that is here from 0 to theta and theta to alpha and alpha to pi minus theta and pi minus theta to that is pi. Total 4 divisions here. So here during positive off cycle, so from 0 to t, here this Vs is somehow E is somehow here, and here sin theta equals to Vm sin theta equals to, suppose this theta is here, so Vm sin theta equals to E and theta equals to sin inverse E by Vm. So this is the formula, and now here Vs is less than E. Here in this case, this Vs, this is the Vs equals to Vm sin omega t, that is Vab. So it is less than E. So now here this is the reverse blocking mode for T1 and T2. So T1 and T2, and Vs equals to E and I naught equals to 0. I naught equals to 0. This is the E. And next here Vs is greater than E, but it is forward blocking mode because we are not giving any Ig current equals to 0. So here we are giving at alpha, but here we are not giving any gate current. So now here is also supply voltage output voltage equals to E, and next I naught equals to 0. So now here is also E and this is also E. So now here at T1 and T2 will conduct, and here is also T1 and T2 will conduct. Vs is greater than E and it is forward conducting mode of T1 and T2. T1 and T2 will conduct. And now here Ig is greater than 0. Ig is not equal 0 and V naught equals to Vs, that equals to Vm sin omega t. It will follow the supply voltage up to alpha to pi plus theta. And next I naught equals to Vs minus E by R, that equals to Vm sin omega t minus E by R. Now here same as pi minus theta to pi, that is here this duration. So here Vs is less than E. Vs is less than E means SCR is in reverse blocking mode. V naught equals to E, same as this one, I naught equals to 0. So now here is also I naught equals to 0. And next off cycle T3 and T4 will conduct. So same as like T1 and T2 will during like this. And now here the circuit turn of time for this one, here it will conduct up to let us take first T1. So T1 means it will conduct up to this one and it will take up to 2 pi plus pi. So now here 2 pi plus theta minus pi minus theta, SCR is in reverse bias, omega Tc equals to. So now here Tc equals to pi plus 2 theta by omega. That is the case for circuit turn of time. So now here what about the average value? So V naught average value equals to integral of 1 by pi. So I am taking up to here alpha 2. So from 0 to alpha is E d omega t plus here alpha to pi minus theta. So that is equal to Vs d omega t, and plus here Vs means here Vm sin omega t, and next pi minus theta to pi. So that is here pi minus theta to pi is here d omega t. This is E. So now here in this case 1 by pi. So now here Vm cos theta plus cos alpha. So that is plus E into theta plus alpha. So this is the case for V naught average value. So now here V naught circuit turn of time. So here current is flowing between from alpha to pi minus theta, T1 and T2, and next here T2, T3 and T4 will conduct. Now let us discuss another converter, same converter, single phase full wave controlled rectifier with freewheeling diode action. So now here that case, here in the previous case the circuit turn of time, here I naught IT RMS equals to here I naught into so here what is the duration here pi minus theta to here what is the duration for this here pi minus theta minus alpha by pi. Here this is the average value, and RMS value equals to I naught pi minus theta minus alpha by pi under root. So this is the case for 2 pi. And now here rectifier with full wave bridge rectifier with freewheeling diode. This is the freewheeling diode FD, and now it is also known as a semi converter. So now here T1 and T2, T3 and T4 will conduct. So during from alpha to pi only they will conduct. In the previous slide without freewheeling diode it will conduct up to pi plus alpha, but because of this freewheeling diode it will conduct up to pi. So from alpha to pi, T1 and T2 will conduct, and next pi to pi plus alpha, freewheeling diode will conduct, and next from T2, T3 and T4 will conduct from pi plus alpha to 2 pi plus alpha to pi, freewheeling will 2 pi to 2 pi plus alpha, freewheeling diode will conduct. So that we will see. So now here T1, T2, T1 and T2 will conduct. So the output voltage will follow the supply voltage. And now here in this case I naught equals to Is. I naught equals to Is only. So this is the I naught, and thyristor current is also here. And now next case here, during freewheeling diode will conduct means here freewheeling diode will conduct means output voltage is 0, and next here source current is 0 and thyristor current is 0, only freewheeling diode current will exist. And next case here next here, so this one, so this is the case for so T3 and T2. So now not this one, T3 and T2 will conduct. So now here I naught equals to minus Is equals to minus I naught. So this is the case, and the thyristor current is 0 if it is take thyristor. And now here this freewheeling diode current is 0. And next 2 pi plus alpha, 2 pi to 2 pi plus alpha, same again, freewheeling diode will conduct. So V naught average equals to 0. So now here, what about the output voltage? V naught equals to 1 by pi from alpha to pi Vm sin omega t. So that equals to 1 by pi 1 plus cos alpha, that is Vm. V naught is equals to. And now here, what about the circuit turn of time here? So that is pi minus alpha equals to omega tc. Tc equals to pi minus alpha by omega. And next, what about the conduction time equals to? Conduction time for this SCR is equals to this one equals to, what is the circuit turn of time? Here circuit turn of time, this is the case for first here SCR is in reverse bias, means here 2 pi plus alpha, 2 pi to 2 pi minus, here pi minus alpha is the circuit turn of time, circuit conduction time. And now here freewheeling diode conduction time, gamma of freewheeling diode current equals to, this is for alpha duration, this is for alpha duration, that is 2 alpha only. Now here the time for which SCR is in reverse bias means, I think this is pi only. So that is pi by omega. And now another thing is here, so IT RMS, IT average equals to, that equals to that one is equals to I naught into pi by 2 pi, that equals to I naught by 2, and IT RMS equals to I naught into pi by 2 pi, that equals to I naught by root 2. So this is the these are the formulas. So now here this is the first one, average value, circuit turn of time, conduction time, and freewheeling diode current, conduction time, IT average, and IT RMS. So it is acts as a semi-converter output voltage. So single phase half wave bridge converter rectifier with freewheeling diode circuit is acts as a semi-converter. So semi-converter means 2 diodes and 2 thyristors, but even though we are having 4 thyristors with freewheeling diode, it acts as a full wave semi-converter. I hope all these concepts are these are the references. I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.